Okay, our next example for algebra review is simplifying a complex fraction. We have 2 over x plus 1 over the quantity x plus 1, all that over 5 over x minus 3 over the quantity x minus 1. So what that means is to write as a simple fraction a over b, or if it just ends up being a whole number like a or expression, then that's fine too. So the more common method is to just go ahead and simplify the numerator and denominator and make them one fraction on the top and the bottom, and then treat the overall big fraction as multiplication by the reciprocal of the second fraction. So that's what we'll do first, and then I'll show another method that can be another handy one to have in your algebra tool belt. So notice on the top that we have different denominators, so we need a common denominator. If you let x equal 2 to just think about this for a second, you'd have 2 and 2 plus 1 is 3. 2 and 3 have no common factors. So they're not, the fact that they kind of look similar and they have an x isn't really counting for anything. We have to go ahead and multiply by x plus 1 over x plus 1, and for the first fraction, and x over x for the second fraction to get that common denominator. Doing kind of a similar thing for the denominator, 5 over x, and that's going to be times x minus 1 over x minus 1. And then we're going to subtract 3 over x minus 1 by x over x. So actually doing that now, we have 2 times the quantity x plus 1 just to show that, yeah, we're going to have to distribute that 2 in a minute. 1 times x is just x. Okay, looking at the bottom, we have 5 times the quantity x minus 1 over x times x minus 1 minus 3x over x minus 1 times x. Alright, looking good. Next thing, we got our common denominator, x times the quantity x plus 1. We have a property that says we can multiply in any order, so that's the same as x plus 1 times x. So we have, on the top here, let's go ahead and distribute the 2, and we get 2x plus 2 plus x on top over our common denominator. I'm going to throw an extra pair of parentheses around there just to show that we're going to take that fraction overall divided by the 1 on bottom here. Distributing the 5, we get 5x minus 5 minus 3x over a common denominator now of x times quantity x minus 1. Next step, just finishing up simplifying the tops of those two fractions. And notice we can combine 2x plus x as 3x plus 2. We got our common denominator. Another thing, do not multiply out the denominators. Leave them in factored form. Top of this bottom fraction, we have 5x minus 3x, which is 2x. And we got the minus 5, leaving x minus 1 factored. You'll see why in a minute. So now we're going to change this, instead of a division or a large fraction overall, we're going to take the top number, multiply instead of divide, flip it, or multiply by its reciprocal. So x times x minus 1 goes on top, and 2x minus 5 gets flipped to the bottom. So at this stage, just note that when you multiply the whole tops and bottoms of fractions, this is what we're going to have. And so the big picture is multiplication on top. Big picture is multiplication of some factors on the bottom. So you can go ahead and cancel any common factors. In this case, it's just the x's. And then another nice thing, in fractional form, if you leave the top and the bottom factored form, completely factored, then that is just fine. If you want to multiply it out and leave it in expanded form, that's totally cool too. But since this is where we're at in this problem, let's just keep it easy on ourselves and call it a day and leave it in that form. So that's it for that one. We're going to look at another method that can be handy. And this is something definitely I'll be using in class to illustrate some problems with calculus around it. Derivatives specifically, by definition. Alright, so another skill in our algebra tool belt. This method involves finding the LCM of all the denominators in our problem. Or I should say the denominators of the inner fractions. So in our problem, that is x, or I should start out by saying the LCM of x plus 1, x, and x minus 1. And that's equal to x times x plus 1 times x minus 1. And then you multiply the overall numerator and denominator by this to clear the fractions. So let's do that and see how this works. Okay, our original problem was 2 over x plus 1 over x plus 1, all that, divided by 5x minus 3 over x minus 1. So we found this LCM, and we're going to multiply the overall numerator and the overall denominator by that. And we can do that because it's equivalent to multiplying by 1. Now here's where students get a little confused. We have to overall multiply that by the top and the bottom here. And so we're going to take this thing and distribute it using distributive property. Take this bottom thing and distribute it to each term in the denominator. Now also remember that when we multiply fractions, that it's like we have to multiply these things like they're over 1. So really the LCM thing is just going to the tops of each of those fractions. So here's what we get. 2x times x plus 1 all over x for the first fraction. Oh wait, I forgot the x minus 1 on the top. There we go. Next fraction, 1 times that holds LCM, x times x plus 1 times x minus 1, then just over the lonely x plus 1. So we're going to be able to clear those fractions now. That's what this is going to do. Let's write out the bottom. Same thing applies. We're going to have 5 times that whole LCM on top, x times x plus 1 times x minus 1, all over x. Okay, next thing, minus 3x, x plus 1, x minus 1 over x minus 1. Here's the fun part. We get to cancel stuff. X is in the first fraction. Now note that x plus 1 can be written in factored form as a multiplication problem times 1. So it is a factor, and we can go ahead and cancel the x plus 1s, x's, x minus 1s. So that clears the fractions, and what we have left behind is 2 times quantity x plus 1, x minus 1, plus x times quantity x minus 1, all over 5 times x plus 1 times x minus 1, minus 3x times x plus 1. So all the fractions are gone. Now unfortunately the top and bottom of this simple fraction is not simplified. It's kind of like partially factored, partially not factored. So I'm just going to go ahead and expand it. Notice here you cannot, for example, cancel the x minus 1s here and x plus 1s. You can't do that because it's just a factor of the first part of these, and they're separated by adding and subtracting here. So again, it's in this in-between form. It's not a factor of the whole thing. We could pull out an x plus 1 in the denominator, but notice we can't pull out an x plus 1 of both terms on top, which means it's not a true factor of the whole top, only at the bottom, and they don't cancel. So the best way to do this now is just expand completely the top and the bottom and combine like terms, and then you're going to be able to call it a day, unless that thing on the top and bottom can be factored and you can cancel something out. But we'd probably be able to see that in the form it is now, and there's nothing that can be factored completely from the top and the bottom. So first thing I'm going to do is I'm going to multiply out or FOIL out the x plus 1 times x minus 1. I'm going to choose to multiply by the 2 at the end. Okay, so then I got x squared, and I guess I'll do the long way, minus x plus x. So that's going to go away. minus 1. Plus, distribute the x squared minus x. All that over 5, I'm going to leave that out for a second. And then we're going to have the x squared minus x plus x minus 1 again. Minus 3x squared plus 3x. So continuing here, notice that those sum to 0, so I have 2x squared minus 2 plus x squared minus x all over 5x squared minus 5 distributing minus 3x squared plus 3x. Combining like terms up top, 2x squared plus x squared is 3x squared minus x minus 2 over 5x squared minus 3x squared is 2x squared plus 3x minus 5. So that is correct and simplified, although in a different form than our answer, but they are equivalent if you went ahead and multiplied out our first answer with method 1, you would get the same thing. So either way is fine. You can do any problem that you're going to encounter in this class by either method. It's just kind of nice to know both, and there will be cases where one is faster than the other, so it's kind of nice to know both.